In our last video, we spoke about how to detect single touch on your screen, on your touch screen. I should have added how to detect swipe as well, but I was too focused on having like multi-touch swipe, like 3 fingers to swipe. But a lot of devices may not be able to detect 3 fingers, three touches at a time, very low-end devices. And you may have to use 1 finger to swipe items across your screen, or whatever reason you're going to use swiping, like some game action that requires swiping. So I'm going to talk about a single touch swipe in this video. So first of all, let's just close all these other scenes here, and I want to create a new scene. Let's maybe a 2D scene, and let's name that swipe scene. Let's just add a script to this. Leave it as is. And it's going to be similar detection as before, with a few extras. In this case, we want to check for the start position and end position of your touch, and that's what we're going to use to determine if a swipe occurred. So let's make 2 variables. Let's call them start position, and let's just give it a default value of 0, vector 2.0, and let's do the same thing. Control C, enter Control V, and call this end position. Great, and we're just going to put the same set of information that we did last time. Function input, and same thing again. If you can't remember what all this means, you can always go back to the last video, which explains this in more detail. If the event input, event touch, screen touch, sorry. And if that event is a pressed event, let's say the start position, we're going to set the start position to wherever was pressed. Start position is equal to wherever the event position took place. Let's go back 1. Else, when release, that makes that position the end position, because it's not pressed anymore, so it's been released, and that will be the end position will be event dot position at that point. And here we're going to check for swipe. So as to not clog up the input function, I'm just going to create a new function called check swipe, or check for swipe, whatever works for you. And there's my beautiful spelling again. Of course, it doesn't exist, so we'll have to create a new one. Let's enter, clear the tabs, and make a new space, and make a new function, and make a new function, and call it check swipe. And of course, it's not a phone, it's a function. We're going to create something called, well, I call it a movement vector, but you can call it whatever you like. Programming people like to call it delta, or delta movement, or something like that. Delta is usually a change in something, but I'm not going to use delta here as to not get confused with process's delta. Process has a delta as well. We're not going to use process here, but I just don't want to use it. So I'm going to call it movement, my beautiful spelling, movement vector, because our distances are measured in vectors in Godot. So I'm just calling it movement vector, and that movement vector is the end position minus the start position. And of course we may want the distance of this, so let's make another variable called distance, and that variable is the movement vector dot length. So this is going to give you the length of that line, or that distance that you move from the start position to the end position is going to give you a length. And for direction, of course we'd like to know the direction, because you want to know what direction you're swiping in, because your game or your program may require you to swipe in specific directions. And to get a direction, we use something called, we're going to use the movement vector again, but we're going to use something called normalized. We're normalizing it. What this basically does is, no matter how long your movement vector was, in our case we call it movement vector, it's going to scale it down to one, a size of 1 unit. So at that point, it's only the direction of that vector is important, and this is why we use it for direction. Rather than if you made if you have a really large screen and you made a very long swipe across, it has a lot more calculation to do to tell you the direction. But if we get a direction at this point, it makes it easier for calculations later on. So we're using this for directions. If you don't understand, you can always check normalized, control click, and it's going to give you a little more information on it. And normalize is something used across many programming languages, so you could also check it online and get a little more information on normalized. So let's head back there. Sorry, swipe scene. Let me save this for now. Oh, I didn't save. Huh. And here now we want to check. I mean, someone may just touch the screen and let go, or touch and their finger tremble a little. We want to avoid false triggers from taps or jitters, so we can just say if the distance is less than, let's say, 100 pixels, we just return. And this is supposed to be tabbed. I don't know why it's untabbed. Right, good. Our error is gone now. So if the distance is less than 100, this is a test for a false trigger. We're just going to return the whole function without any information. So it's not going to do anything after this. But let's go back one. If the distance is more than 100 pixels, we can do a print here for now. Let's say swipe detected, and we could also probably put in whatever direction, in direction and we can use the normalized movement vector, which is the direction. So of course now we can save this and we can test this. That's basically it. With a few tweaks you can actually detect directions and so on. Let's just save this, control save, and let's just play this scene alone, and let's see what the output says here. So if I move to the right, it says swipe detected, and you see some numbers there. That's the normalized direction. If you notice, it will never pass 1.0 because normalized adds up to 1 unit. So this basically is the x value and y value of the direction, and if you draw a triangle, the hypotenuse will be the distance traveled, which will be 1 in our case because this is normalized. If I go to the left, you'll see a negative value for the x. And if I go up, you'll see a positive negative value for y. As you can see, I almost did exactly 1. And if I go down, you'll get a positive value for the y. Let's close this off. So that works for now. So of course we want to figure out what direction we swiped in. So let's go down here and let's just add another if. So in this case we're going to do direction. If we're going to swipe left or right, if direction, that will be on the x-axis. So if the direction dot x is, if you're going in right, if it's more than 0.7, and this is just a threshold value, you can switch to 0.6, 0.8, whatever works for you. The 0.7 is mathematically chosen because this is just a little more than 45-degree angle, because this 0.7 is calculated by the x distance divided by the hypotenuse, which is basically in a triangle cosine, and cosine of 45 degrees angle is 0.7. If you're into maths, that's what it does. So if the direction is more than 45-degree angle, which is 0.7 cosine, which is when you do cosine of 45 degrees, you get 0.7. We're going to say, let's print again, and let's say swipe right, and let's do the same thing for, let's just copy this actually. And let's see if the x direction is less than negative 0.7, because it's in the opposite direction. So opposite values, we'll say swipe left. And let's save this and test it out. I'm just running that specific scene. Let's move this up. So if I move to the right, it says swipe right. If I move to the left, it says swipe left. Yeah, if I move up or down, it just says there's a swipe detected in whatever direction, but it doesn't say swipe right or swipe left because it hasn't crossed the threshold angle of 45 degrees that we set, or 0.7 cosine. Let's just close this. And of course I want to do something meaningful with this. I don't know what happened here. So let's add a color rect as usual. My favorite thing. And let's go back to the 2D view, and we want this color rect to fill the whole area. My idea here is to make a whole background that changes color when you swipe in a certain direction. So let's make this full rect, and of course it's going to get smaller because there's no parent for the color rect. If you notice, if you click layout here, it says this node doesn't have a control parent. We can just add a control here, or let me change swipe scene into a control. So let's right click and say change type and change it into a control. So now that is a UI item, a control item, and what we can do is this is the parent of the color rect, we can put this as full rect. So now the whole background, which is a color rect, fills the whole view rect. Let's save this, and of course we change swipe scene from a node 2D to a control. So in the script we would want to also at the top here say that it extends control. It does not extend a node 2D anymore because it's not a node 2D. And let's save this, make sure it works. Great, so we have the whole background. The swipe information is still displaying at the bottom here. Left, right. Up, down shows nothing except this swipe. Everything is working fine. We should port this to a phone to see if it's working, but let's just add a color change. So when we swipe right, let's just say we want to change the color of the color X. So let's drag the color X across. Dot color will be color, and let's just give it one of the, let's call it aqua maybe. And similar here, Control C, and at the bottom here, Control V, and let's change this to a different color, not aqua. That's something red, I guess. Let's say firebrick red. So every time I swipe right, it's going to change to aqua, and if I swipe left, it's going to change to firebrick. So let's try this. Right, left. So this works fine in the debug window. Let's just port it to my phone and see what happens. Now if you notice at the top here, it says remote deploy. Finally, ADB decided to work on my phone, so I can connect it via USB or Wi-Fi. This is Wi-Fi for me, using ADB, and I can run it directly or deploy the program directly to my phone. But before I do that, let me change the default main program and the applications run into, let's choose, the name of this one is swipe scene. Yeah, so this is our main scene, so none of the other scenes are going to run except this one when we deploy the program onto my phone. And let's save this, and at the top here I'm just going to press remote deploy, but let me set up screen recording on my phone so that you can see exactly what's going on my phone simultaneously. Okay, so deploy, and this is going directly from my Godot engine into my phone. You may notice on my screen nothing is happening at the moment, but on the larger screen here all these things are going on here in the build Android project window. And there we go, it's moving the output into the phone. 66% done, and it's going to go across to my phone shortly. So I have both audios working on my phone and my microphone. So it depends on which one works well, I would use that. So you notice here, it was installed. This is a white background, the color that we put. You will also notice that it's still debugging in the Godot engine at the bottom in the output. If I move left, it says swipe detected in that direction. Swipe left, and the color of the screen turns red. I'm going to move left again to show that nothing will happen because it's already red, but it will be detected on the engine. There we go. If I move up, it's just going to say detected in whatever direction, but not left or right. If I move down, same thing. And if I move right, it's supposed to change into the other color, which is aqua, which is aqua, I believe. Let's swipe again, swipe again, swipe again. So it works perfectly on my phone. This is an actual screen recording on my phone. Let's stop that and move on. Okay, so that works fine. That's nice. But that just checks to see if you move a certain distance, left or right, or whatever directions you decide to use here. You can actually use direction.y instead of direction.x, and that will give you an up or down direction. It's up to you, and you have whatever happens when you swipe in whatever direction you like. But personally, I'd like to know that speed has something to do with it, the speed of my swipe. So if I swipe slowly, I don't want the color to be changed. I want to be able to change the color when I swipe quickly. So let's add speed to this function here. So let's scroll up to the top. And underneath the start and end positions, let's just put 2 more variables and call it start time. And we'll also give that 0.0. Time is a float, so it's not a vector, it's a float value from 0.00001 to whatever. And we'll say the end time. I hope you remember what this colon equal is. We'll also say that's 0, 0. And let's move down a bit now. Underneath event pressed, we want to also record time. So when we touch the screen, we want to record the start time as well. And that start time will be something called time at that point in time. We want, at that point in time, we want something called get ticks, my beautiful spelling, milliseconds, m seconds. This is basically how many milliseconds or how many thousandths of a second have passed since the start of the program. So you're going to get a timestamp at that point. When you press at this point, you're getting a timestamp. And let's divide that by 1,000. Let's divide it by 1,000. 1,000 milliseconds in a second. So we basically changing it into seconds. And let's do the same at the end position here. And let's say end time is equal to the same thing, time dot get ticks millisecond again, and divide by 1,000 to change it into seconds. If you like, you can control click and learn more about get ticks milliseconds. It basically tells you, it returns the amount of time passed in milliseconds since the engine has started, and it will always be positive. And it will wrap after roughly 50 million years. So we have a lot of time to play with when we're using that. Let's go back to swipe scene. Let's save this for now. Let's go into check swipe. And we want to check for these new speed stuff that we added. So let's make a new variable here and let's call it speed. Yeah, I spelled it right this time. As you know, speed is equal to distance divided by time. In our case, we call distance over duration. And we forgot to create a variable for duration. So let me just do that above here now. Variable duration is equal to the end time minus the start time. And let's create some space here because we want to test if this duration tab, if by any chance the duration was less than 0, or let's say 0, let's say less than or equal to 0, we just want to return the whole function without any errors. And why? Because 0 gives errors. When you divide by 0, it gives errors. So let's just return. So we don't want any dividing by 0. Because next we are using speed is equal to distance over duration, and if duration was 0, you're going to get an error in calculations because anything divided by 0 is infinity. And of course, all I want to know now is if the distance is more than 100 and if the speed was more than, let's say, 800 pixels per second, because that's what the measurement will give you. That's when I want the swipes to occur. Let's save this and let's test it out. Okay, so I started a screen record on my phone. Let's just run this. Make sure it's working here. So if I move quickly enough, it's going to change. I need to check this before I move on. Okay, I noticed a little debugger error when I was running the program. It wasn't performing as it should. So I'm just coming back to fix it. There was a warning, a debugger warning earlier. That's the yellow warning that says this is not going to give precise calculations because anything after the decimal point is being thrown away. So basically, time that takes milliseconds over 1,000 will throw away anything extra. We need to change the 1,000 into a float. So just add a 0 at the end, and you'll notice the highlighting is gone. So now that is fixed. If we run this now, we'll see that swipe is working perfectly. And if I move slowly, no swiping is taking place, but if I move quickly, it changes. Now let's just run that on my phone. I'll start the screen recording on my phone, and let's just run this directly on my phone now and see what happens. You notice it moves a little more quickly. Okay, so if you notice now, it's running on my phone. If I move to the left, it changes to red. If I move to the right, it changes to aqua. All the information is being debugged on the output screen as well as I do it. And if I move again, you can see it works back and forth. If I move slowly, you'll notice there's no change. But if I move beyond a certain speed, in our case it's 800 milliseconds, 800 pixels per second, it works. And that's how you enact swipe on a touchscreen. I hope this was informative, and check me in my next video.